Hey folks, and welcome to the latest video in the SAM for IBM Rhapsody series. I'm Andy Lapping, and in this video we'll use SAM to perform reverse engineering. Now first, the AI assistant has to be able to read your code, and while some desktop clients provide file access, most web clients don't, and so SAM provides tools to allow file access. Now I can of course point the AI assistant directly at any file or folder on the hard drive, but I can also encapsulate that information into SAM folders. For example, the SAM profile includes a folder that gives AI access to the Java doc for the Rhapsody API. Now as long as the files in those folders are textual in nature, then SAM can serve them up to the AI assistant, which means you can reverse engineer pretty much anything into a model. Now that might be supported languages like C, C++, Java, but also anything else you want represented in a model. So JSON, JavaScript, batch files. As long as you can tell the AI how to represent it, it can be modeled. Here on my hard drive, I have a folder containing some PlantUML files, and using a Visual Studio plugin, I can visualize them. For example, there's a class diagram with classes that have attributes, operations and relationships. There are state machines, like this one for the alarm system class. In a subfolder, there are some sequence diagrams. Let's reverse engineer some of that into Rhapsody. Now, in this sample profile, I have a SAM folder that is pointing at that folder on the hard drive. Note that path can be absolute or it can be relative to the profile. Over here in Claude, let's start by asking what folders are actually available. There we can see the one containing our PlantUML and also the Java one from the SAM profile. Now let's ask what's in the PlantUML one, and since it has subfolders, we'll make sure to ask the AI to look in there too. There are our PlantUML files. Let's reverse engineer some of them, starting with the class diagram. And since we know we're going to import the state machine as well, let's import the operations as triggered operations, which we can then use on that state chart. There are our classes, attributes, triggered operations, and relationships from that PlantUML. And we even have a diagram showing them. Now next I wanted to reverse engineer the state machine, but as luck would have it, Claude itself started having issues, not responding to prompts and eventually wiping out my chat. Now Anthropic are usually pretty quick to rectify back-end issues like that, and so rather than re-record the entire thing, I thought it would be a good opportunity to demonstrate picking up where we left off. So I went for a coffee, came back, and I started a new chat. As this is a new chat, I'll include the instruction to read the alarm system state machine PlantUML from the available folders, and make sure it's added to the existing alarm system class. There is our PlantUML state chart in Rhapsody under the alarm system class. Next, the sequence diagram, but once again Claude started having issues, and so I went for another coffee. I gave it some time to sort itself out, and then I started another chat. Once again, I'll include the instruction to read the PlantUML file from the available folders, and I'll also prompt it to read any available skills first, as Rhapsody sequence diagrams can be a bit tricky when created through the API. But there we are, a pretty faithful rendition of the PlantUML sequence diagram. Now, Claude issues aside, this is a really good result. Using SAM, you can reverse engineer pretty much anything into a Rhapsody model. Now of course, Rhapsody itself supports reverse engineering of C, C++ and Java, but even if you are reverse engineering one of those languages, SAM can go beyond the guide ropes that the built-in capability imposes. Well, that's it for this video. Over the course of the series, we'll explore other use cases and capabilities of SAM for IBM Rhapsody. But for now, thanks for watching.